Welcome to Value Gene Inside Conversations.
Today, we're moving into the third part of our series on manufacturing misconceptions.
We've already spent some time dissecting the hidden beliefs that can limit performance in process design and people management.
And today, we're turning our attention to the hardware, the physical assets.
Which is such a critical piece of the puzzle.
It is. When we look at food manufacturing specifically, performance challenges, they rarely stem from a lack of hard work or even technical know-how.
Right.
Plants invest capital, teams are working incredibly hard, yet throughput and cost performance, they often stall.
And in our work, we find that these gaps trace back to hidden assumptions.
Which brings us to the core thesis of this whole series.
It's rarely the machine's fault. It's the belief system running the machine.
Exactly. We're looking at this concept of drift. When we talk about physical assets, conveyors, ovens, fillers, the damage rarely comes from some, catastrophic explosion that makes the evening news.
It's much quieter than that.
It is. It's the cumulative effect of treating misconceptions as valid decision rules. And the cost, it gets paid in minutes lost, in yield waste, and in reliability issues that just become part of the background noise.
The normalization of problems. You stop seeing the crack in the wall because it's always been there. So looking at the research and the fieldwork, we've identified 4 major misconceptions regarding physical assets.
Yeah.
Let's start with the money. The first one is the tight budget trap.
We see this constantly. It's usually framed as discipline. A plant manager or a VP of operations will say, our budget is tight this year. We need to focus on affordable fixes.
Just keep things running. The big spend can wait.
Exactly. And on the surface, that sounds responsible. It sounds like prudent management.
Right. It feels like being a good steward. You aren't asking for a massive CapEx, capital expenditure check from headquarters. You're just keeping the line moving with what you have.
Yeah.
So why do we consider that a trap?
Because if you dig deeper, what looks like discipline is actually just normalized mediocrity. Breakdowns, they stop being treated as signals that the system is failing, and they start being treated as features of the plant. The operators adapt, maintenance compensates, and the schedule just gets built around all the interruptions.
So you're paying for the problem, you're just not fixing it.
Precisely. We call this the economics of patching. Recurring, affordable fixes. They often cost significantly more than a rebuild would have over the same period.
But because the loss leaves the building in small increments,
A belt here, a bearing there, a few hours of overtime.
it never triggers a major decision event.
Exactly.
That conveyor belt example from the notes, I mean, that
It's-
feels like a classic death by 1,000 cuts scenario.
It's a perfect case. This was a facility where they were replacing belts on a line every single month.
Every month.
Every month. Now, the expected life of those belts was 9 months. So they were getting, what, about 11% of the asset's life cycle?
And nobody flagged this. That seems like an incredible waste of material.
No one flagged it because the cost of a single belt is relatively low. It flies under the procurement radar.
I see.
But when we looked at the data, that gap meant 8 extra stoppages over the life cycle. Each stoppage was about 7 hours of downtime.
7 hours each. So that's 56 hours of production loss capacity that the plant just absorbed.
It just absorbed it. And what was the root cause? Was it just a bad machine?
That was the assumption, right? It's an old machine. It eats belts.
That was the story. But the reality was a lack of standards. The belts were being forced onto full-length conveyors and basically micro-damaged during installation.
So not the asset's age. It was the process.
It was the installation process. But because the fix was cheap, no one investigated the cause.
There's another example here that I think is even more damaging because it hits revenue, not just maintenance costs. The industrial oven.
This is where that tight budget trap gets really dangerous for the business model. We saw a plant with a large industrial oven that had a hot spot on the left side. It was consistently overbaking the product.
And the fix was too expensive, I assume?
The rebuild was considered too high for that fiscal year. So operations just compensated. They ran the oven slower or they accepted higher scrap rates.
But here's what they missed.
They missed that sales started losing accounts. Customers complained about inconsistent browning. The plant thought they were saving, say, $50,000 on a repair, but they were bleeding hundreds of thousands in lost contracts.
That is a terrifying disconnect between the factory floor and the bottom line.
It is.
We see a similar dynamic with utilities, right? Specifically HVAC. In food manufacturing, temperature control is obviously critical, yet it seems to be the first thing cut from the budget.
It's viewed as a luxury. We observed a plant that refused to invest in proper HVAC upgrades. The system would fail, but only during the extremes, maybe 2 months out of the summer.
And leadership just treated a proper fix as optional. We can push through it.
That was the mindset. But pushing through implies you can maintain standards, which, of course, they could not. During those 2 months, waste quadrupled.
Quadruple.
The temperature fluctuations affected the line's stability. Think of chocolate or dough behavior. And product consistency just tanked.
And the raw material got blamed. The operators got blamed.
But the system itself remained unchallenged. They were saving money on CapEx, but bleeding cash in operational waste.
So why does this happen? If the math is so clear to us looking at the spreadsheets now, why isn't it clear to the leadership teams on site?
It comes down to risk and incentives. Managers are often judged on very short-term results, quarterly or annually.
And a major CapEx proposal invites scrutiny.
A lot of scrutiny. You have to build a business case, you have to defend your assumptions to a board, and if it fails, it's on you. It's a personal risk.
Whereas a repair invoice is just the cost of doing business.
Exactly. A recurring repair invoice flies under the radar. It doesn't trigger a board meeting. So the rational choice for a manager trying to minimize personal exposure is to keep patching.
True discipline isn't about spending avoidance then.
No, it's about financial intelligence distinguishing an investment from a recurring loss.
That leads us right into the second misconception, which is about who makes these decisions. Often, when we walk into a plant, there's that one person, the veteran.
The belief here is, our veteran has been here 35 years. He knows every bolt, every bearing. He knows what to invest in and what to fix.
And to be fair, we have immense respect for those veterans. They're often the reason the plant is still running at all.
Absolutely. Their institutional knowledge is invaluable, but there is a danger.
The danger is when that experience becomes the ceiling for improvement.
Exactly. The plant improves only within the bounds of what that veteran already knows.
It creates a situation where the solution space is limited to how we've always done it.
We saw a perfect example of this in a raw material handling process. This plant was feeding raw material bags into the process using a forklift.
Okay.
Every batch required waiting for the lift, loading the pallet, positioning it. It caused a recurring delay of about 20 to 25 minutes per cycle.
But because it didn't technically break, nobody saw it as a problem to be fixed.
Precisely. It was just how the process works. The veteran operational leadership, they didn't see it as a problem because it was reliable, even if it was slow.
They weren't aware of other options.
Right. They weren't aware that vacuum conveying systems had evolved to the point where they could move that same material in 2 to 3 minutes.
That's a massive reduction in variability.
It is. But because the veteran didn't know the technology, the option was never on the table. We see this capability erosion often. Plants stop keeping up with the outside world.
They rely on internal memory rather than external engineering standards.
And there was another example of this with a viscous liquid line pumping something thick like syrup or batter. This plant had a recurring issue where the piping would clog. The veteran solution was manual intervention. Get the rod, take the pipe apart, clean it out.
It was hard work, but they were good at it.
They optimized the manual cleaning, but they completely missed the engineering solution.
Which was?
Modern inline sensors and automated flushing systems could have prevented the clog entirely. They could sense pressure changes and react before the blockage formed. They were optimizing a task that shouldn't have even existed.
And this reliance on internal know-how, it often leads to that we can do it ourselves mentality. We see organizations avoiding external engineering support to save on fees.
That's a classic trap. We worked with a site that finally approved a major investment in new machines, a big step forward. They decided to manage the execution internally to save on engineering costs.
How did that play out?
Poorly. 3 months before the machines were set to arrive, the factory was completely unprepared. Electrical work was incomplete, the layout wasn't resolved, vendors hadn't been managed.
And the pressure mounted.
2 of their internal engineers actually quit, so the savings on that engineering overhead
Evaporated.
and then some. Costs inflated through delays and change requests. We had to bring in a specialist team to rebuild the layout and sequencing. And the interesting part is, once we applied proper engineering rigor, the revised design actually made space for 2 extra machines within the same budget.
That's the takeaway. Organizations have to combine that experience with modern engineering capability. You can't let how we've always done it prevent you from redesigning your constraints.
And speaking of constraints, that brings us to misconception number 3, the idea of the obvious bottleneck.
This is one we hear in almost every kickoff meeting. We ask, Where's the bottleneck? And the team immediately points to a machine. It's the filler, or it's the oven.
The belief is our bottleneck is obvious and static. We invest where it is slow.
But our perspective challenges that immediately.
Right. Bottlenecks are not static. They shift based on ski mix, they shift based on ambient conditions, and very often they shift based on staffing.
That concept of the manufactured bottleneck is fascinating. It implies management decisions, not equipment limits, are often the true governor on output.
We see this all the time in labor-intensive areas of food manufacturing, like packaging or decoration. We had an engagement focused on revenue uplift, where the site claimed they were at 100% capacity. They were telling sales, we can't ship any more product.
But the reality on the floor was different.
We looked at the decoration station. It was staffed with one person. That single person capped output at roughly 45 units per hour.
And that was the constraint.
That was the constraint on revenue. By adding a second person, output jumped to 90 units per hour.
Wow.
That simple labor decision, likely made months ago to save a headcount, was actually costing them double the throughput on a high-demand SKU.
It seems like plants often lack what we call a living constraint view. Can you explain what that means?
A living constraint view just means understanding that your max speed isn't one number. Your rates have to be defined by SKU family and by staffing standards.
So it's a matrix.
It's a matrix. If you don't have that, you're measuring yourself against historical peak hours that might have happened under completely different conditions. You need to know, if we run SKU A with 3 people, the rate is X. If we run SKU B with 4 people, the rate is Y. Without that, you're flying blind.
So if you're a listener running a plant, you need to stop asking, what is the bottleneck? And start asking, where is the bottleneck right now with this crew?
Exactly.
So we've discussed budgeting, we've discussed reliance on history, and we've discussed bottlenecks. The fourth misconception is one that drives operational folks crazy: the art of changeovers.
This is the belief that the guys know where the parts go and setups take as long as they take. It treats the changeover as a performance by the operator, like an art form rather than an engineered process.
It accepts non-repeatability. It assumes that if a certain operator does the setup, it takes 30 minutes, but if another does it, it takes an hour. And that's just life.
Right. If a changeover relies on memory, oh, I think this guide rail goes here, then you're managing uncertainty, not a process. We worked with a confectionery plant where changeovers were routinely running over 150 minutes.
2.5 hours. That kills your efficiency.
It does. And it wasn't because the operators were lazy. It was because there was no defined ready state.
They were just figuring it out as they went.
They were searching for parts, choosing which tool to use, and correcting adjustments in real time. They were effectively reinventing the machine setup every single time.
And we also see the missing prerequisite failure here. This is where planning falls apart.
This is critical. You can plan the downtime on the schedule, but if the prerequisites aren't managed, that planned downtime immediately becomes unplanned downtime.
Sure.
We see lines sitting idle because a spare part is missing, or a vendor wasn't scheduled, or a special tool is locked in a cabinet nobody has the key to.
The mechanical work was planned, but the readiness was not. So how do we fix this? How do we move from art to science?
Changeovers have to be treated as an engineered system. First, you need concrete, ready-to-run definitions. Second, you need poka-yoke.
Poka-yoke.
It's a Japanese term for mistake-proofing. Think of a USB plug or a SIM card tray. It only fits one way. In a factory, this means labeling and keying parts so you cannot put the guide rail in the wrong spot.
You're designing the error out of the process.
You're removing the guesswork. And finally, we need to manage the prerequisites, parts, tools, vendor windows, just as strictly as we manage the production schedule itself.
So if the tool isn't at the line 30 minutes before the stop shouldn't happen yet.
It shouldn't happen.
So what does this all mean for the leaders listening today? We've walked through these 4 misconceptions: the budget trap, the veteran ceiling, the static bottleneck, and the art of changeovers.
If we synthesize these insights, the goal is not just to reduce maintenance costs or speed up a single line. The goal is to restore economic and operational control.
It feels like a shift from defense to offense.
That's a great way to put it. Most plants are stuck in a mode of managing around constraints. They're coping. They're patching the belt. They're relying on the veteran to bypass the issue. They're accepting the bottleneck.
They're coping.
The shift we're advocating for is redesigning constraints.
Moving from coping mechanisms to actual engineering solutions.
Precisely. Whether it's using data to justify a rebuild instead of a patch, bringing in external expertise to leapfrog an old process, or defining your changeovers as a system, it's all about taking back control of the asset's economics.
And that economic control is what allows a food manufacturer to compete, regardless of whether they have the newest factory on the block or a legacy site.
The legacy sites can be incredibly profitable and efficient, but only if they shed these misconceptions. If you treat the old machine as an excuse, you lose. If you treat it as an asset to be engineered and optimized, you win.
That's a powerful place to leave it. It's about mindset as much as it is about machinery.
It always is.
Thank you for listening to Value Gene Insight Conversations. To deep dive, please see the show notes. For more on food industry topics, visit valuegeneconsulting.com or subscribe wherever you get your podcasts. If today's discussion resonated with you, please do not hesitate to reach out to us to continue this dialogue. Have a great day.